Education Bureau in collaboration with Addis Media Network. I'm the presenter, Teacher Mamo. Today, we will discuss about the real-life applications of rational numbers. But before we start the present lesson, I will remind you what we have seen in our previous lesson. If you remember, in our previous lesson, we have seen operations on rational numbers. Particularly, we have seen how to add, subtract, multiply, and divide rational numbers. Just to specifically touch the points, in the first case, in adding two or more rational numbers, we have seen different cases. The cases are adding rational numbers having the same positive denominator and adding rational numbers having different denominators, right? Look, the first scenario, if we have two fractions a over b and c over b, we can directly add these two fractions using their numerators. You take the same denominator, then after you can directly take a and c and add them, right? So adding these two fractions is a straightforward activity. Okay, this was one thing that we have seen in the first case. The other one is you may have two fractions a over b and c over d. Okay, in this case, both b and d should be a number different from 0. Especially in this case, we need to take positive denominators. Whenever we have two fractions having different denominator, we have seen how to add these two fractions using different method. If you remember, the first method that we used to add these two fractions is taking the LCM of the denominators b and d, okay? After taking the LCM of the two numbers, we were able to make similar the two fractions in a way to have the same denominator. Once you convert these two fractions into their equivalent form in a manner having the same denominator, the next activity will be adding the two numerators directly. Okay, this was one of the methods that we used in adding two fractions. Do you remember the second method that we used in adding two fractions? Well, the other method is if we are asked to add a over b and c over d, we can use cross product method. That means we multiply a with d, then b with c, right? Then after, we take on the denominator the product of the two, b times d. So these were the technique that we used in adding two fractions. Similarly, if you have more than two fractions, you can follow the same procedure. All right. After the discussion of adding two fractions, we have also seen properties of additions of fractions. Do you remember the properties of additions of fractions? Well, if you say closure-ity property, you are correct. The first property that we have seen in addition of rational number is about closure-ity property. Closure-ity property refers to if we have two rational numbers, the sum of any two rational number is again a rational number. Okay, this is what we mean by closure-ity property. The second property associated with the property of addition of rational number is commutativity, right? Commutativity means a property satisfying this form, a plus b is equals to b plus a, okay? If a and b are any two rational numbers, you can add in a plus b form or b plus a form. The result will be the same. This property is called commutative property. So this was the second one. The third property that we have seen regarding additions of fraction is associativity property. Here, associativity property is a property satisfying this condition. A plus B plus C is equal to A plus B plus C. Such property is called associative property. And the fourth property that we have seen in addition of two rational numbers is the zero property. The zero property is a property possessing this condition. A plus 0 is equal to 0 plus A, which is A itself, right? And the fifth property that we have discussed in the property of addition of fraction was A plus its inverse, its additive inverse results 0, okay? You can write these two terms in different order, okay? It's okay, it satisfies the commutativity property, so you can also make it in this way. So these were the properties of additions of fractions or rational numbers, right? The other thing that we had in our previous discussion was we have seen how to subtract two rational numbers, right? So, for example, if you have A over B minus C over D, you can directly apply the cross product method that we used for additions of fractions. So, in this case, this gives us AD minus BC over BD, okay? We don't have too much property like we did for addition of rational numbers. The only property that we observe in subtraction of rational number is closure-ity property, meaning that if you have two rational numbers and take the operation subtraction, that means the difference between any two rational number is a rational number. Therefore, there is a closure-ity property under subtraction. All right. So we don't have commutative property in subtraction. We don't have associative property and the like, right? So the only thing that we have seen is the closure-ity. The third point of discussion that we had in our previous lesson was we have seen how to multiply two rational numbers like A over B times C over D. Do you remember how we made or how we calculated the product of two fractions? Well, the product of two fractions requires only multiplying numerators with numerators and the denominator with denominator. So this gives us AC over BD. And the last one was division of rational numbers. But before we started the division, we have seen properties of multiplications in rational numbers. Like we did for addition, there is closure-ity property in multiplication of rational numbers, meaning that if you take any two rational number, the product of any two rational number is a rational number. So there is a closure-ity property in multiplication of rational number. The other thing is take any two rational number and find the product. If A over B times C over D is given, adjusting the order of this fraction do not affect the outcome. So this is the same as C over D times A over B. So multiplication possesses the property of commutativity. So there is commutative property under multiplication of rational numbers. There is also associative property in multiplication of rational numbers, right? You can take any three numbers, A, B, C, okay? If you take this thing and multiplying these three numbers in this order, A times B times C is the same as A times B times C. Since this is true for any rational number, we can say that multiplication is associative. There is associative property in multiplication of rational number. but this property do not hold for subtraction. And lastly, do you remember what we did in our previous lesson? It was division of rational number. Suppose we have three numbers A, B, C. A divided by B is equals to C. You all know this symbol is a symbol that we use for division, okay? Sometimes you use a slash notation to represent division. Good. So in calculating divisions of rational number, we need to apply some principles. Look, A is called dividend, B is called divisor, and C is called quotient, okay? You need to be familiar with the terminologies in divisions of rational number. So these are the terminologies. When we come to the division part, if A and B have the same sign, the quotient C will be positive. If A and B have a different sign, the quotient will be negative, okay? You need to keep this thing in your mind before you start calculating divisions of rational numbers. So these were what we have seen in our previous lesson, okay? I hope you did the homework regarding the previous lesson. All right, so let's start our present lesson. Today we will discuss about the real-life applications of rational numbers, okay? 1.5 is the real-life applications of rational numbers. So this topic is the last topic in the first unit, okay? Basically, we have 5 major subtopics in the first unit, and 1.5 is about the real-life applications of rational number. This will be the end of the first unit. So when we come to this topic, we will see how we apply the concept of rational numbers in our day-to-day activity. In our day-to-day activity, we can find the concept of rational number almost everywhere. You can find it in your home. Wherever you go, you interpret things using rational numbers. So in this particular lesson, we will be focusing only on 2 particular real-life applications. The first one is simple interest. Okay, one of the real-life application of rational number, we use it in simple interest. Here, interest is denoted by capital letter I, and it's defined by the formula P times R times T. Okay, here P refers to the principal, the money borrowed or loaned, right? And R refers to the rate. This R is given in the form of percentage, and T refers to the time or the length of the period that the money is used. So we need to know this formula before we start observing some problems related with simple interest. You need to know this formula, okay? So I is defined in this manner. Now, we can rearrange P, R, and T, one in terms of the other in this way. So if you take this equation and divide both sides by R and T, the result gives us P is equal to I over R times T, okay? Divide this equation both sides by RT, and principal will be I over RT. You can also express rate in terms of the other parameters. So from this equation, we can also derive the rate in the form of I over PT. Okay, you can also express T in terms of the other parameter. So T is defined as I over RP. Okay, so you need to be familiar with this formula to understand problems related with simple interest. Now let's see certain examples regarding simple interest. The first one, in our first example, we have Alamu invested BER 40,000 in a bank at a rate of 10% per annum. What will be the interest he will be receiving after 5 years? What will be the interest that he will receive at the end of say 5 years? Okay, here in this problem, there is a concept of simple interest. Alamu invested his money 40,000 in a bank at a rate of 10% per annum. Per annum means per year, okay? I will repeat it. Per annum means per year. So he invested this much amount of money in a bank at a rate of 10%, okay? So the question here is, what will be the interest that he will receive or he will earn by the end of the 5th year? Okay, so before you start solving this question, you need to properly put the given information mathematically. So here 40,000 is the money that he invested. So this is the principal, okay? Usually the principal is the money borrowed or loaned. So we have the principal, we have the rate, which is 10%, and we have T, or the time. Okay, we have this information. So you need to put the given information. So it's given that the principal is 40,000. The principal is 40,000. The rate is 10%, and the time is 5 years, right? So the required thing here is the simple interest. Required is I. We don't know the value of I. So to calculate the interest that this person is going to receive by the end of 5 years, you need to apply the first equation, right? It's a must to know this formula. Unless otherwise, you cannot properly put your answer. So we follow this formula. I is equal to P, which is 40,000, times the rate, which is 10%. Okay, 10% means 10 over 100, okay, which is 0.1. So you need to convert this percentage in the decimal form. So in place of R, use 0.1 times T is 5. Okay, you need to multiply these three numbers. 40,000 by 5 is 200,000. Multiply it by 0.1, the result gives us 20,000. Okay? This number tells us the amount of money that he will be receiving by the end of 5 years in the form of simple interest, right? So this is how we answer these kind of questions, problems related with simple interest. Let's see some other examples regarding simple interest. Okay, child two received BER 120 interest by investing her money in a bank. If the rate is 3% and the length of period is 4 years, what was the principal amount of money that she invested in a bank? Okay, in this second example, the question says, child 2 received BER 120 by investing her money in a bank, right? If the rate is 3% and the length of period that she invested in a bank was for 4 years, what will be what was the principal amount of money that she invested in a bank? Okay, here, what is given, the interest is given, it's about 120 BER, and the rate is 3%, and the period or the length of period that she invested her money in a bank was for 4 years. So based on this information, we are asked to determine the principal amount of money that she invested in a bank, right? So let us put the given information properly. What is given? The interest is given. Okay, it's given that the interest, usually denoted by I, is given, which is 120. The other information is we have the rate, which is 3%. 3% can be written in the form of 0.03 because 3% means 3 over 100. The other thing is the time is given. Okay, T is given, which is 4. Okay. Well, here we are asked to calculate the principal. Okay, the required thing here is the principal. Okay, so as we have seen earlier, the principal can be calculated in terms of I, R, and T. We said that principal is I over RT. Okay, now we can directly substitute everything that we have here in this formula. So I is 120 and R is 3%. Or 0.03 times 4, okay? Now multiply the numbers on the denominator. 0.03 times 4 becomes 0.12. Okay, so make it like 120 over 0.12. Okay, you can use your calculator, or you can be very technical in simplifying this kind of numbers. Multiply both the numerator and the denominator by the same number. This will not change its result. So this becomes 112,000 over 12. Okay, now you can divide 12,000 by 12. It's a very simple calculation. Dividing this gives us 1,000. Okay, so this number tells us the principal amount of money that child 2 invested in a bank for the given period of time, right? So this is how we calculate problems related with simple interest. Well, next, we will see some other real-life applications of rational number, like discount in a certain shopping or in a certain marketing. So now let's see problems related with discount. Here, like we did for simple interest, we don't have a certain formula to calculate the required information in the case of discount. But there is some conceptual approach to answer problems related with discount. Let's see this thing using example. For example, a pair of shoes originally costs per 1,200. If the shoe is on sale with 25% off, what is the current selling price of the shoe? What is the current price of the shoe? Okay, here in this question there is a shopping. Okay, there is a pair of shoes originally costs per 1,200. If the shoe is on sale with 25% off, meaning that if there is 25% discount, what is the current price of the shoe? Okay, so there are two things: original price of the shoe, and there is a discount. So based on this information, we will try to find the current price of the shoe. Okay, already we have the original price of the shoe, which is 1,200 per. The discount is 25% off, meaning that 25% of 1,200, right? You need to calculate this value first. So 25% means 25 over 100 times 1,200. Okay, you can simplify 25 over 100 in the least simplified form. So this becomes 1 over 4. 1 over 4 times 1,200. Okay, multiply 1 by 1,200 and divide it by 4. This gives us 300. Okay, this gives us 300. Now, this 300 is the discount. Okay, so now to calculate the current selling price of the shoe, you need to take the difference between the original price and the discount. that will be the current price of the shoe. So take this difference, the result is 900. So here, this number tells us the current price of the shoe, okay? Whenever you go for shopping, you need to have a good understanding of rational number to determine the current price and exact discount for any items, right? So this is our first example. Let's see some more example regarding discount, okay? Let me give you one more example on this issue. The original price of an apartment. The original price of an apartment is BER 5 million. If the selling price of the apartment has 10% discount, what is the current selling price of the apartment? What is the current selling price of the apartment? Okay, here in this specific problem, there is the original selling price of an apartment, which was 5 million. Now they are selling the apartment with 10% discount. Okay, so based on this information, you are asked to determine the current selling price of the apartment. As we did before, the first thing that you need to do is calculating the discount in this price, right? So usually we calculate the discount by multiplying the percentage of discount by the original price of the item, okay? So multiply 5 million by 10%, okay? 10%, you need to convert this 10% in decimal form, and 10% is 0.1, okay? 10 over 100 or 0.1, okay? The least simplified form of 10% is 0.1. So multiply this product, and when you multiply this thing, the result becomes 500,000, okay? Or $500,000, right? This is the discount based on the information that we have here. So now the current selling price of the apartment is the difference between the original price and the discount, okay? Take this difference, you will get the current selling price of the apartment, okay? So this difference gives us 4,500,000, okay? This is the required answer for the second example, right? So these are some of the real-life applications of rational numbers, okay? So based on what we have seen so far, I will give you a homework regarding 1.5 or regarding real-life applications of rational numbers, okay? Okay, the first question is, if Mr. Tadesse invested 2 million in a bank at a rate of 15% per annum, meaning that per year. What will be the interest that he will earn by the end of 7 years? By the end of 7 years. 7 years. Okay. So this is the first question for your homework. The other one, let's see some, I will give you some problems related with discount. Okay, take this. If the price of if the original price of the car was 1.5 million, and the car is on sale 30% off. What is the current selling price of the car? Selling price of the car. Okay, so you'll have these two homework. The first one is about simple interest, and the second one is about problems related with discount. I hope you got some concept from our previous examples. So based on the example that we have seen before, I need you to attempt these two questions. So don't forget to properly show all the steps that are required to obtain the required answer. Okay, these are your homework. This is all for today. We have seen two problems regarding real-life applications of rational number. You can also create your own example that shows the real-life applications. These are what we have for today. So this is the end of the first unit. I hope you enjoyed the lesson. Thank you for listening. Bye-bye.
These humans are making letters with their bodies. Humans can run, skip, jump, and even